Alright guys, this is the last video for Unit 1, so let's go ahead and get it finished. We're going to talk about how matter is divided today in more detail. Remember that matter is into two categories, into mixtures and pure substances, so let's go ahead and talk about mixtures. Mixture is a combination of two or more substances in which each pure substance retains its own chemical properties, its individual chemical properties, okay? And we have two types, which we've already discussed. One is heterogeneous, and that is a mixture that does not blend smoothly. You can see the different parts. The example we talked about earlier was salad, or on an earlier video was salad. Another example would be water with sand in it. That would be a heterogeneous mixture. A homogeneous mixture is one that has a constant composition. That means you can't see the different parts. It's most of the time referred to as solutions. And one example of that is gasoline. It's made up of several different liquids, and so you can't see the different liquids separately. It's all in one. Now, we can separate mixtures. One separating technique is called filtration, and this technique uses a porous barrier. That means you put something, or you pour the mixture through something like a porous barrier, like a filter, to separate a solid from a liquid. This is why you use filters in your coffee pots, so that it catches the solid coffee grounds, but you get the liquid benefit underneath the filter. Heterogeneous mixtures are easily separated by filtration. Now, distillation. This is a technique that is actually based on the differences in boiling points of substances. If you have two things mixed together and those two substances have a different boiling point, you can heat the mixture up, the liquids up, and cause them to boil. And once they begin to boil, they have the one with the lowest boiling point starts to have a vapor. And so that gas rises up, goes into a condensing tube, which cools the vapor back down, and it can be collected in another beaker or another container. And so by heating up this solution, you can separate out the substances because they have different boiling points. And the one with the highest boiling point remains in the original container. Now, crystallization can also be used. This is a technique that results in the formation of pure solid particles of a substance from a solution containing the dissolved substance. So this is basically like a supersaturated solution, if you remember that from physical science. So once the solution holds enough solute and it's full and it can't hold any more, it becomes supersaturated. It becomes saturated. But if you add one more piece of solute than it can hold, it becomes supersaturated, and sometimes that can cause crystallization. And here's a picture to show you what that kind of looks like. Now, chromatography is used to separate mixtures also. And this is a technique that's going to separate the components of the mixture, which is going to be either a gas or a liquid, and it's based on how fast that gas or liquid, or the different components of this gas and liquids, can travel across another material, and it's usually a solid piece of material. The mobile phase, which what I was talking about earlier, is usually a gas or a liquid. That's the part that's actually moving through chromatography. The stationary phase of chromatography is the solid, the component in which the gas or liquid travels. So the stationary phase is usually like a solid. An example would be chromatography paper. Now, the reason the separation occurs, if you have a solution and they have the different components of the solution have different rates that it can travel across a medium, then some are slower than others, some are faster than others, and as they travel across that medium, you can see the separations begin since they travel at different speeds. Now let's look at elements and compounds. Remember, these are the pure substances. We just finished talking about mixtures. Now we're going to go more in detail about pure substances. An element is a pure substance that can never be separated. It can't be separated into something more simple. It's just not possible. It doesn't matter if you try physical change or chemical change. It's not going to happen. Now you have 91 naturally occurring elements. You're going to find these on the periodic table that you have in the back of your book, and you are going to need your chemistry book later in this video, so you may want to grab it. Now the rows going left to right across the periodic table, the horizontal rows, are called periods. The columns, which go up and down, they're vertical, they're called groups or families. Now a compound. A compound is when you combine two or more elements chemically. That means they've reacted with one another. And so it's two or more different elements. I'm sorry. It can't be the same element, so it'd be two or more different elements combined chemically. Now, chemical compounds can actually be separated, unlike elements, but you have to use external energy like heat or electricity. Now, this is an example just to show you how you could use electricity. This is the electrolysis of water, and as you can see, it's hooked up, these bottles of water are hooked up to a battery. And the battery electrons are going to go through the cathode on the right up through this bottle, and there would have to be another thing connecting these two bottles at the top, and then the electrons travel back down. The battery charge, the electric charge travels back down the bottle on the left and back into the anode of the battery. Now, on the right-hand side, this bottle, since the cathode is the part of the battery going into this bottle, it's the one that carries the negative charges. So hydrogen is pulled out of the water solution because hydrogen is positively charged. So it pulls out and it starts making bubbles, and they're hydrogen bubbles because the gas is being released and separating itself from water. Then as the electric current flows through the bottle on the left, it actually has positive charges, and the oxygen is negative normally, so it's attracted to this positive charge, and the oxygen starts to bubble and be released as a gas and separated from the water. Now, a compound, we have over 10 million compounds, and chemical formulas help to show which elements and the number of elements involved in a compound. For example, water is H2O. That tells us that there are 2 hydrogen atoms and 1 oxygen atom. That also tells us they have a 2-to-1 ratio. For every 2 hydrogen, you have to have 1 oxygen. Now, sodium chloride. This tells us we have 1 sodium ion and 1 chlorine ion. And they have a 1-to-1 ratio. For every 1 sodium, you have 1 chlorine. Now let's talk about the law of definite proportions. This means that a compound is always composed of the same elements in the same proportion by mass. So if you have a compound that have the same elements, they're always going to have the same ratio, like we just talked about. So it doesn't matter how much water you have, each water molecule always has a 2-to-1 ratio, no matter how large or how small the sample. Now, you can calculate percent by mass. Like if you want to know how much oxygen is in a water molecule by percent, we can calculate that. So what we're going to do now is we're going to practice calculating percent mass of oxygen in water. Alright, the first thing we need to remind ourselves of, and you need your chemistry book because you need to look at the periodic table on the back, that if we have, when we're looking at the periodic table, we have the element symbol. This is the atomic number. 6 is the atomic number. It tells us how many protons and electrons. 12 is the mass, so it tells us the mass of carbon. So you need to make sure you understand that because we need to use that. So if we have H2O, if you'll remember, the formula for percent mass is the mass of the element that we are looking for, and in this particular instance it's oxygen, divided by the mass of the compound. And then after we do that, we're going to multiply it by 100. But you have to do the division first. So we've got to find the mass of the compound. So to do the mass of the compound, we look at hydrogen on the periodic table. We look at its mass. We see that it's mass of 1. And so we have 2 hydrogens, so we say 2 times 1 grams, because that's how many we have, equals 2 grams. Okay? Now oxygen we only have 1 of. So that would mean we have 1 oxygen times the mass of oxygen is 16 grams. So that's going to give us 16 grams. So to find the compound's mass, we say 16 grams plus 2 grams equals 18 grams. Now, to find the percent mass of oxygen, we have to take the mass of the element, which was 16 grams, divide it by the mass of the compound, which is 18 grams, and that's going to equal 0.89. Once you multiply that by 100, you get 89%. So the percent mass of oxygen in water is 89%. Now it's time for you to practice. Pause the video, do these 2 problems, and then resume the video when you're ready to check your answers. All right, here are the answers. Make sure if you didn't get them right that you put a star next to it and write a question down so we can make sure we answer that once you get to class. Let's go ahead and summarize for today, and I want you to use a newspaper article summary, and that means what you're going to do is you're pretending like you're writing a newspaper article on this video, and you need to come up with a catchy title. So just come up with a catchy title that summarizes the information found in this video. I'll see you in class.